Okay, the first question to find the PDF of z. And the first method is convolution method. We can divide it into two conditions. The first condition is when z is less than 2 or equal to or more than 1. We can find that the PDF of z is equal to integrate 1 from 1 to z and get the outcome is z minus 1. The first condition is that when z is less than 3 or more than or equal to 2, integrate 1 from z minus 1 to 2, we can get the PDF of z in this interval is 3 minus z. Okay, the second method is the geometric method. First, we can draw the figure of the joint PDF of xy. And this slope is x minus y is equal to z. And since the shaded area, its area is 1, so we can find that when the point of xy is in the shaded area, the PDF of the joint PDF of xy is equal to 0. Otherwise, it is equal to 1. Otherwise, it is 0. Okay, when z is more than 3 or z is less than 1, there is no intersection between the slope and the shaded area, so the PDF of z is 0. When z is less than 3 or more than or equal to 2, first we can find the CDF of z and then get the PDF of z. It is equal to 3 minus z. Okay, similarly, when z is less than 2 or more than or equal to 1, the intersection is shown as in this figure. We can also first find the CDF of z. It is equal to z square of z minus 1 times 1 over 2, and finally find the PDF of z. It is equal to z minus 1. The PDF of z, it is the finger is shown in these two fingers. It is the same. And question 2, given that the joint PDF of xy it is equal to 1 over a times y squared times x, and y is more than or equal to 1 and x is less than y and more than 1 over y. First, we can draw the non-zero definition region of fxy. It is shown in this figure. Then, to find a, so that fxy is a valid joint density function. Okay, according to the definition of the joint PDF of xy, integrate the PDF of xy from x is equal to 1 over y to y, and from y is equal to 1 to infinity. We can get that the outcome is 2 over a. It must be 1, so that we can find out that a is 2. Okay, the third question, find the marginal density functions of x and y. First, to find the marginal density function of x, we can divide it into two conditions. First, when x is more than 1, we can say that when x is more than 1, integrate fxy from y is equal to x to infinity. We can get that the outcome is 1 over 2x squared. And when x is less than or equal to 1 and x is more than 0, in this point, for example, integrate the PDF of xy from y is equal to 1 over x to the infinite. We can get that the outcome is 0.5, half of 1. Okay, and finally we can find that the marginal density functions of x is shown in this figure. Okay, to find the marginal density function of y, integrate the joint PDF of xy from x is equal to 1 over y to y. From this point to this point, for example, we can get that it is equal to ln y over y squared for y is more than or equal to 1. Otherwise, fy is equal to 0. So the figure of the marginal density functions of y is shown in this one. Okay, to verify that these two functions are valid density functions, according to the definition of valid density functions, integrate the PDF of x or y from the minus infinite to the infinite. We can get that they are both equal to 1, so that we can verify that both of these two functions are valid density functions.